So, on to the corpus evidence. So, to make the claim that melodic sequences with lower information content are easier to hold in memory than those with high information content, I trained an idiom model on a corpus of 622 melodies using the pitch and scale degree viewpoints. If you're not familiar with idiom, what results is an output of all of the musical tokens the model was trained on, along with their associated information content. To take an example that might be a bit more familiar, in order to give a concrete example, so I'm not just rambling on here, here's an excerpt that Pierce uses in his review article to explain information content using a cadential passage from Schubert's octet in D major, trained on a subset of the Essen folk song collection. Above each note is an approximation of how expected each musical event is based on the model. Low probability events, like that F moving down to the A, have high information content, and more expected events, like the leading tone resolving to the C prior to stepwise motion, are more expected, and thus have less information content. This seems sound from a music theoretic perspective. So if we were to then imagine these notes happening, let's say, isorhythmically, for ease of imagining it, over time, we might imagine the notes filling up the window of perception, as sort of shown in this chart here. Or we could imagine it in real time using this animation. So here we see the unexpected events filling up the sort of finite bin of memory quicker than expected events, which fill up the bin less. So returning to the corpus, events that happen more frequently will have a lower information content, which is essentially a tautology based on the way a multiple viewpoints model calculates the probability of events. So instead of relating frequencies of events to information content, I can instead show a couple of examples of 5-note patterns that I've extracted from the corpus that represent low, middle, and high information content. Before showing them, let me play 3 examples and take a moment to guess for yourself which patterns are taken from each of the 3 categories. Each 5-note pattern is preceded by a brief cadence. As you may have guessed, the examples here were played in ascending order of information content. The first example comes from the one from these here, pictured here, the second here, and the first here. I've depicted them using these charts here as a series of items filling up the bit of memory over the course of time. The dotted lines refer to some sort of possible capacity limit. And if you would like to see how this might then sort of look in real time, I also created animations to sort of make that visualization here. So you can see that on the far left, the one with the lowest information content ascends least quickly, whereas the one on the right, the furthest one, has a much larger slope, indicating that this would be filling up the bin of memory much quicker. Let's see. So we can then zoom out, and then instead of looking at just exemplar categories, arrange every 5-note sequence in this corpus that I encoded from the most information content to the least, from top to bottom. And here we see a clear violation of the null hypothesis that all 5-note sequences have equal information content. While this might be somewhat convincing, if you are a psychologist, these numbers might not be as convincing until they're mapped to human behavior. So in order to do that, I ran a small experiment and I'm in the process of designing my first full-fledged pre-registered report as my first, quote, experiment I should have done in my dissertation. Essentially what I did is have trained musicians complete a scale degree recall task similar to the anecdotal experiments that David Huron puts forward in Sweet Anticipation on page 66 if you'd like to look it up. The experiment worked by having participants listen to a short piano cadence followed by a pause and then a note, or a probe tone. After hearing the note, they had to identify which scale degree was played in movable do notation. Since it's always better to show rather than to tell, this is basically what the task was 39 times over in 3 keys over 13 notes with do represented at the octave. Well, which scale degree was that? Maybe someone knows, maybe someone doesn't, but it was scale degree fa in the key of E. So, essentially, so if the frequency facilitation hypothesis was true, it would predict that scale degrees that were easier to process would be recalled more accurately and more quickly. The rationale would be that scale degrees that occur more often, a la the Crum-Hensel and Kressler profile, would have lower information content associated with their occurrence, be given a calculation in idiom. Or basically the way that I've currently done it, which is just using a information content measure as derived from a corpus of humdrum, which I'm referring to as mid-idiom, which correlates with the viewpoints that I'm using in my dissertation research. So of course I'll do this in a much more principled way when it comes to the actual modeling and pre-register it, but this is close enough for right now. So this would hopefully also then be the movable do corroboration to some of the findings in the absolute pitch literature that say that frequently occurring notes are easier to recall than not as frequently occurring notes.